Yeah, so it was a project in digital humanities involving 8 partners. I mean, the list of partners and all the details are not very relevant, but the main point is that we worked on digital humanities by combining skills and not pretending that anyone, I believe, I mean, everybody has a different definition, but I believe that digital humanities is the intersection of different competencies, and maybe one day will be one its own discipline with its own specialists. Maybe, I mean, there's already specialists, but it's mainly the intersection of knowledge of different groups. And in this context, sorry, I am saying things that are very dangerous now. Basically, we combine the only thing that I'm trying to say with this is actually that we had partners from libraries, partners from actually what I would call digital humanities, contradicting what I said before, but people from the humanities who are working with digital methods, and groups from computer science. So that's actually the main information that you need for now on this. So we combine different skills and basically the idea behind it is to work on newspapers, and I will try to say why it's interesting. And to use the data from the libraries, make sure that what we do is useful to the libraries, goes back to them, design methods in computer science that are novel for computer science, that make progress in computer science, but also make sure that it's not just interesting research for computer science that cannot be applied to anything, but also have the humanists in the loop and make sure that this is actually useful for them, as in so many cases, the diverging needs of different disciplines do not serve each other very well. Everyone has different goals. Some want to publish code, someone just want to publish research in computer science, but are not so interested in providing data, and so on. So we have this very tight group with the goal to make sure that everything that everybody is doing is useful for the others. Newspapers. Why do we work on newspapers? The reason is that there's lots and lots of pages of newspapers that have been digitized for 20 to 30 years, starting in the 90s, the first main big digitization campaigns. And they are still ongoing because there's so much material. There's lots of languages, lots of stores, different qualities, also different qualities of digitization, because the documents that were digitized in the 90s are not digitized as well as the ones done currently, and also the extraction of text is not of the same quality. And one of the difficulties is that the documents that were digitized and OCR'd in the 90s can hardly be re-OCR'd and re-digitized today, because there is so much to digitize that it's very hard for any library to ask its funding body or the government or ministry to say, hey, can we redo what we did 30 years ago? Of course, the government would always say no. They would say, please do something else, so you can write it in the report and say we did 2 million more, and do not say we redid what the government, what the taxpayers already paid for, because it was bad. You know, I mean, that's just politics, but. So basically, we have to deal with this. So it's very interesting for lots of people. It's very interesting, obviously, for historians. It's very interesting for the public. It's very interesting for lots of disciplines. But the problem is that these newspapers are hard to access. And from the research point of view, we like to work with them because it's hard. We like good research problems. And the newspapers, I mean, being a computer scientist, it's nice because you can see here they are folded. In the middle, the newspaper was folded, so you have a lot of text in the middle that is hard to grasp. You have stamps when it was archived in the library. You might have pieces of the newspaper missing, and it's written very small, especially the old newspapers. They are written small. They are meant to be read frequently. They are not meant to be saved, so they are actually often poorly preserved. So you have a lot of issues. And it's meant to be bought on a regular basis, so they are meant to be cheap. Therefore, they are printed on cheap paper with low quality ink quite often. So you have all these problems that make OCR difficult, that make finding the structure of the newspapers difficult, and so on. So it has for a research project, it has a nice combination of something useful for many people, for a very large public. and something hard. So the idea is to give people, to give users access to these very large collections of documents, support the quantitative analysis, because it's one of the typical cases of large amounts of data that no one can read in their life. No one can read everything in their life. And, but of course, we don't want to make a black box. Someone was showing a black box earlier today. No one wants a black box. It was actually the Library of Finland, who was a partner of this project. No one wants a black box. Everyone wants to understand what happens. So we don't want to do quantitative. We don't want to support quantitative analysis and not do it, and basically maybe guide the qualitative research with quantitative tools. And the challenges, I mentioned them already, the low quality of sources, the fact that there's not always adequate tools, especially for newspapers. There's very few digital libraries that are specialized in newspapers. There's a few. But quite often, if I think of the French National Libraries, they have Gallica, which is very good state-of-the-art. But Gallica is a large digital library that has newspapers, but does not exploit all the features, all the metadata that exists in newspapers in a specific portal. And that's true about very many digital libraries. Just to make sure, I think this will probably be very obvious to everyone, but just to make sure that we're on the same page, if I dare to say page. The main challenges that we start with when we use newspapers, historical newspapers, is that we start from digitization. Digitization is a picture. You just have an image, and you have to get all the content out of it. So obviously, one of the challenges with newspapers is that they talk about a lot of different topics. The same page is addressing completely different topics with text written by different authors. And the first thing you want to do is get the meaningful semantic unit and find the articles. So for instance, this one highlighted in red. And you see immediately it's not that easy because you have some framing, you have some horizontal line, vertical lines, but actually the vertical lines do not really separate the horizontal lines. Sometimes separate, sometimes not. And this is a longer article. There's a picture which might be a separator, but actually it's not, and it might go on below, but actually it's going on the right. And all this for us human readers is kind of obvious, but for a machine it's very hard to grasp. And this part is completely different. It's echoes, so it's like short stories. Here you have a full story, but if you, in this part, basically every paragraph is talking about something different. And you have all these many different levels and different structure. Then you want to extract the text. The text is never extracted perfectly. And most of the time, it's exactly the same. We are used to reading images. We are used to reading text. There's a lot of redundancy that is there to also make it less costly less costly in a cognitive sense for humans to read. And actually, when there's errors, sorry, I don't know why I left the example in French, but when you read this, but it's a French-speaking session, so it's when you read this as a human, I mean, there's also studies that were done by psycholinguists, I think, where you can switch the words, you can switch all the letters in a word, and as long as you keep the first letter in place and the last letter in place, you read it. Any human can read it very easily, but every machine will fail. So here you can read this text. I can read this text very easily. For instance, this 1, apostrophe is L apostrophe. It's the article. A parser will get confused, but for me it's very obvious. I mean, I don't even have to think, but okay, it's L apostrophe. And there's an accent a diacritic that should not be here. That's absolutely not a problem. You know, the brain basically discards it immediately, just ignores it because it's not relevant. It shouldn't be here, and it doesn't matter. Just like when you read the text with typos, which we do more and more in many places, social networks, but not only, also now professional emails very often. We discard them, we understand anyway. Obviously, the problem is that when you do indexing, when you want to search a large collections of millions and millions of pages and you want to find the relevant articles, if the word is not properly extracted, the index will be wrong and you will not find the document. And this is a major issue in digital humanities, or in the humanities in general, is that when you build a sub-collection to work on a specific research question, you build your sub-collections with queries most of the time, and your queries might miss some documents, and you build a theory, you validate a theory based on the sub-collection that might be missing all the documents that contradict it, and you don't know if these documents actually agree with your theory, disagree with your theory, and you don't know if it's 90% of actually what you should have found, or if it's 2%. And then, so there will always be a big question mark on every work that is done based on digitized documents because of that. So we decided, and I think that's why we're here, to do semantic enrichment, to provide some semantic metadata on the text. And that means to find persons, locations, organizations, the most classic named entities, but it can, of course, go much more deeper than that. Maybe you could say a word about it. It can be much deeper. It can be completely different categories. Basically, especially nowadays with AI, you just define the categories, you give examples, and you can define that your named entities are plants or whatever is your need. And the idea is maybe actually to, instead of improving the OCR and being so obsessed with OCR when you know that false OCR full of errors can be read quite easily, the main important thing is to get the document, and is actually to get things right for the things that are queried most often, the things that are useful for building connections. And that's usually these names, locations, or the plants, if you want to work on plants, if your research question is about the plants and the discovery of, I don't know, plants and around time and when they appeared in news and when they were discussed and about what. And anyway, there's so many questions that so much research can be done with newspapers. So this is about, so this text is about William II, the Kaiser of Germany, and Lord with Mouse, as there was an incident, well, there was something discussed in the British Parliament. And basically what you want to know is that you want to always find that this is William II, so in French now it's correct. But this Lord with Mouse became Lard with -MOU space DTGU, and that will never be found. So if you want this incident, you might likely query with mouse, and this will never come up. So we want to focus on making sure we can find the persons, locations, organizations. And the other thing we do is, this is named entity recognition, but we also do named entity linking, which is linking these people to external knowledge bases, such as VIAF or Wikipedia or so on. And the idea, well, is to differentiate. I mean, if you have Kaiser in different newspapers and in different times, it's not the same person. And the nice thing about this is also that when you have Guillaume II in French, it's the same person as William II, it's the same person as Wilhelm II, and it's always, you can always link to the same identifier, and then you can actually do cross-lingual analysis. So the goals, I think I've covered them. Large impact, big problems. And one of the key goals we had was to be able to work with documents and collections in any language, integrate any corpus, and be applicable to any domain. And that's actually why in the project we worked on the period 1850-1950 to have a lot of collections, but something kind of bound in both directions. And to verify, that we could apply things, our results to several languages and different collections. And to verify that it is actually useful, what I said in the beginning, to verify that it is actually useful for the humanities in general and not just for one research topic. We had these digital humanities partners, and actually they were distributed in a way that we hope can demonstrate that the results are applicable more generally. So we have the historians from Finland. Actually, Mikko is one of them. Maybe skipping this talk because he's here. Sorry, so you would have been allowed to skip it because you know all of it. Sorry, you were not. You were behind someone. Yeah, so I have to be careful now. So we have the brilliant historians from Finland. No, and they were working on the. Now I'm stressed. On the emergence of the national sentiment in Finland, and that involves documents in Finnish and in Swedish. We had people working on literature in French and actually kind of working on gender-related topics like women and trousers and how it was perceived in the news, because in the beginning it was shocking, and how it was approached and discussed. And in French newspapers, and we had the historians working on German-speaking newspapers, working on remigration, and also in German, people working on media studies. So we had these different domains, different languages, and if all of them tell us, thanks to what was done in this project, we could find new knowledge in our domain and answer research questions that we could not answer before, then we believe it helps to assume that it's useful far beyond the project. And to sum up, basically we start from digitized newspapers. We don't do this. We separate in article. We have this pipeline going up. We separate the newspapers. So we build the semantic units to get out of the pages, which are a soup of different topics. We find the text, and then we find the named entities. We link the named entities to language-independent knowledge bases. We find the opinion, the stance, or actually the polarity of the opinion towards any mention of a named entity. Is the Kaiser mentioned in a positive context, negative context? And we can do that on millions of pages, and then you can learn trends and see what happens. And again, it's something that is language independent in its representation, because you can have negative can be -1, neutral 0, and positive 1, and with, of course, all the array in between. And we want to find also novelty, event detection. So when is a new event mentioned in the newspapers, which you can also use to see how information is spreading across Europe and things like that. And it's also represented in a language independent way with named entities and with markers and with concepts that are also related to knowledge bases. And that gives us this box in the middle, which is a language independent knowledge base. This can be accessed with the interface that I will show very briefly afterwards. And then you have all the tool, you have one more layer where we developed it, which is a bit more empirical, and where we develop tools to allow the analysis of this language independent knowledge base. And the idea is all of this is open, the knowledge base is available, the platform is available, so it's open to development of new tools. And the knowledge base is accessible by search, but all the tools are also available in the platform. One thing I will not discuss much is that also we did a lot of experiences of topic modeling, because now I'm talking about named entity recognition, event detection, and that's metadata at the article level or within the article. It's very refined semantic data, but of course with topic modeling, you can find keywords that define articles or pages or newspapers, depending on what you give as input. And we did a lot of that in the project also. Yes, and we had good results in named recognition and linking. And gladly, because our goal was to have approaches that work in every language, we had good results in every language of the competition organized by my neighbor in 2020, which I joined in 2022. So it's all very connected. Maybe I'm actually taking all the content of your talk now.
It's a great introduction.
Because Matteo, I'm sorry, because now that I said it, I've said that Matteo was working in Impresso, which is a project that is very related. Also working on historical newspapers, so you will see a continuity in the talks. I will say a few words on how we do, yes, I still have time, on how we do this named entity recognition and linking, and basically how we developed, in general, tools to do many of the NLP tasks that are very common. Let me rephrase. There's a lot of NLP. NLP is a very active field. A lot of things happen. There's actually also a lot of money. The industry is very motivated in doing NLP, but not so motivated in doing NLP for historical documents with OCR issues, because that's obviously not a very big market. Sorry. I'm sure everybody knows that. And that's why also we have a responsibility as academics to actually go there, and there's lots of interesting research problems. And we were, I mean, the first question we asked ourselves in the project, I mean, in the computer scientists doing the semantic enrichment was, well, first of all, how can we just apply what exists for social networks or for web pages analysis and financial data analysis? Can we just apply that to historical newspapers and maybe it's enough? And for that, you need to have a text with OCR problems, text that is corrected and manually corrected, and text that is manually annotated with whatever task you want to evaluate: name entity recognition, name entity linking, event detection, stance detection, or what I mentioned earlier, the polarity that is expressed towards an entity. And most of the time, we don't have that. Or if we do it, it's very costly, it will take a lot of time, and we will have it for one type of OCR errors for one document. So we decided, and whatever we will find out will be reliable for this type of OCR errors for this document. It's very hard to generalize to documents that have been digitized since the 90s and OCR since the 90s with different algorithms, different qualities, different types of quality of images, different qualities of OCR, and all of this. So we decided to reverse the problem and synthesize noise. So actually, there's lots of existing data sets because of the strong interest in NLP. There's a lot of data sets for name entity recognition, linking, everything I said, on contemporary documents without OCR problems, without digitization. So we thought, okay, we can use all of them if we manage to inject the noise, and we use the tool that was validated as being a good representation of preservation issues and the damage that ensues in documents. So we took the text, contemporary text, generated an image, put noise on the image. Actually, I will show this instead of talking about it. We take text. This is about crisis in Yemen a decade ago. We generate this text from, we generated an image from contemporary text, and then we have a lot of ways to damage the image. Bleed through is when simulating what happens a lot when you digitize newspapers, when the text from the backside shows on the front side, because the paper is so thin. Other small traces, you can also have blurring, you can have, well, the ink can move when you touch it, make some traces. Anyway, all kinds of noise, we can put them at different levels, we can combine them, and then we do the OCR from these damaged images, and that gives us a huge variety of OCR problems, OCR levels, types of OCR problems, types of OCR errors. And then we can see how well the contemporary state-of-the-art NLP tools are working on this data and compare it to the clean data, initial data, compare the performance on the initial data to the performance on this type of text, this type of text, this type of text, this type of text, type of text. And then we have a lot of variety of different OCR quality, and then we see how much it impacts basically any NLP task, any NLP task, sorry. So obviously we see, I skipped a few tables, but obviously we see, so you have a word error rate is the number of words that are not properly recognized. The percentage of words that are not properly recognized by OCR. Character error rate is the percentage, in short, the percentage of characters that are not properly recognized or placed by the OCR. And delta is the difference, it starts at 0, is the difference between in this case, named entity recognition, the difference between named entity recognition for clean text and named entity recognition for this level of word error rate in blue. So obviously, but it's always good to check first. Obviously, the worse the OCR, the worse the performance of named entity recognition. But what is already interesting is that you can see cutoffs. There's always a moment when the OCR is so. There's a moment when the OCR reaches a point when I can actually tell that there is no point doing named entity recognition, and you can kind of predict the performance And that might actually save a lot of time to a researcher or to a librarian. You can tell them, okay, I looked at the quality of your OCR. Don't invest any money on name recognition. It's wasted money. Just first redo the OCR, first redigitize or something. And anyway, so first that helped us to get a lot of, that helped us to see the problem. And of course, that also helped us to develop ways, once the diagnosis is done, and you have a lot of data with different levels of errors, you can more easily start designing methods to remediate to this, and that's what we did. We also created our own data sets and followed the Impresso guidelines, so my neighbor, and exported what we did using Transcribus for those who know, and the results will be integrated to Transcribus. It's actually happening at the end of the year. At least it's our goal. It's ongoing. And the method we did, I mean, I will not detail it, but the method we designed for this clay competition that I mentioned before, very briefly, because I know most of you are not computer scientists, but we just designed a specific model where the trick was simply to add more transformer layers for those to whom this makes any sense. And the idea is that the transformers help to get more context. And the assumption was that because the text is not so reliable, because the OCR is creating, well, it's making the data unreliable, the text unreliable, we want to look at more context, assuming that we actually have to look a bit further to get more reliable information. And looking at adding transformer layers gives us more context, that gives us more information that is reliable. And therefore, it actually improves the performance in all the languages. So in some cases, we need one layer, sometimes two layers, and more than two layers gives all the fitting, and that's was to be expected. Anyway, I said I wouldn't talk too much about the model. And this gave, well, strong improvements compared to the baseline. But like I said before, the baseline was very weak because nobody really cared about this problem before. And the last thing I think I wanted to say is I wanted to say a word about the platform, because we have a platform that everyone can access. It's a NewEye platform where you can see everything, and maybe that's, well, you can see that's where the metadata kind of becomes useful, because you can navigate not with keywords, you can navigate with person names, and not only with person names, but actually with identified, disambiguated person name using the knowledge bases. And then you can go through the newspapers, and you can also extract, create a sub-data set, keep it in the platform, analyze it in the platform, but also, most importantly, because everyone has their work habits, you can also export it, download it, and use another tool that you are used to using outside, and so on. So all the code is available. What else should I say? Yeah, the code, the papers, everything is available. Collaboration is welcome. The project is over, but we have a lot of, well, we have subsequent activity and funding for a few years, luckily, to continue working on the platform and other topics. I wanted to also highlight, so this, I mean, this was already clear. So yeah, our goal was to ease access to collections of historical newspapers, manage, improve, reduce the noise, do some semantic enrichment. I wanted to highlight topic modeling and post-OCR correction. So the task of improving the OCR after the OCR was done without going back to the image, because that's actually a very realistic case of what we have to do when we deal with documents digitized in the 90s. And everything else is also, yeah, that was the motivation. If I may, or maybe I'll do it later. I had a word of advertising. But it's not related to this at all, actually. Well, I do it. Sorry, I said it too late. I said it so. I've been hearing, because I'm since this year I'm the chair of the steering committee of TPDL, and I'm not sure how many of you have been going to TPDL or submitting papers to TPDL. If you can raise your hand. I thought a few. I knew about a few, but I think not so many. And I thought everything I heard yesterday and this morning would be very relevant to TPDL, so I want to highlight that this is a very good venue for sending papers because the conference is very interested in applications, also applications of results of information retrieval indexing, creation of metadata, application of the metadata, and it struck me that the conference is all kind of looking for its audience, and this is and I think the audience is here, so I wanted to advertise it. And next year it's a very nice location. Yeah. Anyway, that's it. That's it. Sorry about this. Maybe I'll go back to this conclusion slide. I think.
Thank you, Antoine. Thank you very much, Antoine. I think that at least one visitor is sitting in the first line because with respect to the location of the event. But thank you, and please. Are there any questions? Peter, obligatory.
So, am I correctly understand that the name entity linking is not agnostic to the time, so it's the time of the publication is somehow regarded in this process. So, for example,
initially not.
There is a person name who attended in the 19th century and 20th century, 20th century, and there's a wiki data linked to the 20th century person, but the newspaper appeared in the lifetime of the first person. So it's not linked to the person who is not born at all.
Yeah. I think now, I mean, actually in the last, this year we have started to take that into account, and it seems to show some improvement. The problem we have is that, I mean, many of the people from the 19th century are not in Wikipedia. So it works for the most well-known, but in the general case, it's not that helpful.
Yeah, but do you link persons who are in the Wikipedia but live after the publication of the journal?
We try to, we try to take that into account. I mean, I think it still happens, but we try to factor this in. Sorry, I didn't really answer your question. But I mean, we take it into account, but it's not like a fixed rule. It's some of the parameters. So I cannot say we don't have a rule that if the person matching this has a birth date after this, we reject. It's kind of a it's AI, so it's a bit. We don't know what happens, but we factor that in, and we noticed that it shows an improvement, but it still happens. I mean, last time we made a demo, we had 10 mentions of Jennifer Aniston. She was not born. She wasn't. I mean, it's another one, but 1850 to 1950, that might be an error.
Okay, Agnieszka.
Hi, thank you for a very nice talk. But I wanted to ask you about your OCR. Are you implementing your own OCR, or using some open source libraries? And if you're using some open source libraries, which one do you use?
So in the project, the OCR was done by our partners in. Oops, sorry about this. Our partners in Rostock in this work package. And everything they did, I mean, they work very closely with the team of Transcribus, if you know that.
Okay.
And the models are some of the models are I'm not sure if all the models are in Zenodo, but the models are also in the Transcribus platform. Okay. So you can find them there. Yes, I'm not saying anymore. Okay. So but it's not the problem is Transcribus. I mean, it can be a problem with that. Anyway, the economic model is that to support it, they have you have to pay, unless you can say, I'm a PhD student, this is for my research, but if it's for your company, you will be charged to use the models. But I mean, it's a cooperative, so I want to say this to defend them. It's a cooperative, and they use this to actually maintain the service. It's not a company.
Testing different types of OCRs, but from a different perspective. but from our experience, the best one available for free was Padus OCR, and it's a Chinese OCR, Padus OCR. It's the fastest and the best accurate, so maybe you want to check it out. So Padus OCR, it's really good.
Okay.
We are using it for text scene recognition. So
Text what? Sorry?
text scene recognition,
okay.
like signs on the streets and writing on the package, like on your shampoo. So this is pretty difficult challenge, and it's working, really well. So if you can try that.
Yeah.
That's
But in this case, I mean, of course, we should try. But in this case, we have really models trained for historical newspapers in different in the languages of the project. And the error rates were actually very under 1%, so it's starting to work very well. I mean, handwritten text recognition remains a problem, and of course, scene text recognition is very difficult. But for printed text, it's getting quite okay. But actually, the main problem we have, like I said before, is that if you digitize something today and OCR it today, it will work very well. But if you OCR today something that was digitized 30 years, 20 years, 10 years ago, it would not work very well. And quite often you have the OCR of something that was digitized 30 years, 20 years, 10 years ago, and you don't even have the image anymore, or the image is in bad quality. So you actually have to ask the library to go get it in the storage facilities that they have in the countryside, 300 kilometers away, call a truck, and of course they will never do it. Unless you have a very good reason. Or depending on their model, I don't know. Some might do it, actually.
One more question. So I was wondering, are you building your NER models from scratch? Because you showed your transformer models, and you showed that you are using 2 or 3 layers depending on the model. So you are building it from scratch, training from scratch, or you are using some
no, we use some
models?
we use some language-specific birds.
Okay.
Yes.
Okay, so
and
that's good.
Refine them a bit. Yeah.
Because I think it's quite a good idea to train it on from conversation speech, whatever. Just train it on this step, and then fine tune it on your program, and maybe it will be better starting point. I will
Sure.
Train it.
Yes. We that's what we do actually.
Oh, so that's great. Thank you.
You're welcome.
Very nice comment.
Okay.
That's
Sorry. Any other questions?
I need too much time.
I have a question regarding so I understand correctly that generally digitalization projects that depend largely on OCR, that you want to give some content access to the users, whether there can be other ways of doing it, if not a link or whatever. So then your approach was that you kind of assessed whether some approach of content or information extraction, how good the OCR needs to be for a particular approach, right? This is let's say that this is now a standard, let's say, because usually it was sometime that you were digitizing, making OCR, your goal was that people should read it and everything should be correct, But now I understand that this is a different approach, right? So we try to do as good of an OCR and then apply a method of information extraction, right?
It's, it was kind of a part of the process. It's not, first we wanted to see how bad it is and how, the first question was, can we actually use the standard, the state-of-the-art named entity recognition tools that you can find in any natural language processing conference with very high performance? Can we just apply that to historical documents with OCR problems? And to answer that question, we wanted to have a lot of different levels of OCR. And then we could observe that there's a moment when the performance, the impact of the OCR quality is kind of going up very strongly, which allows us to make some recommendation, but they are always a bit hard to generalize because to the general case. And then we use these collections to develop methods that are robust to this OCR noise. So we did both. Mainly the contribution, I think, was to develop methods that are robust to noise. and that can do better. I didn't highlight this. I was talking a lot about the first part, that's true. But the main idea in the project was to develop methods that are robust to the noise and that will maybe not work as well for Twitter data or contemporary data from the web, but that will work much better than the state of the art from natural language processing conferences when it's applied to historical documents with OCR problems. So basically being robust to OCR and being able to find named entities and events in spite of a text that is not perfect.
One more question about topic modeling. It was in red, maybe I didn't catch it. Is it still in works? Topic modeling is still in works, or you resigned from doing topic modeling because it was on the
It was right because just for a reminder for me to mention that we did this too, and I did not develop it in the in the document. It was not right because it's not good.
Okay.
It was right because it's also something we did. It's also something where we made experiments on the impact of OCR on the performance of topic modeling. And that's it, because I thought it's very relevant here. So I thought I didn't have time to detail it in the talks, but I wanted to mention that we also have done that for a more document level metadata, maybe.
Thank you.
Or collection level even.
Thank you, Antoine. Any other question? Okay, I will check the chat. Okay. So thank you very much, Antoine, once again.
Thank you very much.